That's the tool I wanted. All right, so this screen is suspiciously dim. Let me see if I can fix that. Menu. Right. All right, that's much better. Got a new display on here. I swapped with my wife, so the settings are slightly different than I'm used to. But it will, I mean, it's slightly larger than my last display too. So hopefully the computer can handle it as I'm also looking at that and streaming off of the notebook. So we'll see how that is. Until then, in between streams, I continued working on the deep learning neural network, and we got it working. So where we had left off was right before updating the weights. So that would be down here. Basically, well, I guess like right during this time, getting the const one, the layer 1 delta set up. And so I was able to do the matrix multiply, and I followed the solution in the book, and that led to this fun algorithm here. I think we had finalized writing the dot matrix function, and that wasn't working the first try, and I also got that working. So it wasn't quite as simple as I thought it would be. I had to do a transpose and then another map, but like writing every step down on paper of what I was supposed to be doing was the solution for me to get this. So I don't think I was going to get that on stream, where I was trying to hurry myself for that. Miguel, good morning. But the end result is that I can play around with the number of streetlights that I generate and the number of times that I iterate through each set of streetlights, and run this, where I get to see, okay, well, the error is going down and the accuracy is going up. And so I can play around with it, say, okay, well, what if I have more streetlight data? And okay, well, it starts higher accuracy and it gets to 100% by the end. And what's happened, like the way it's checking is down here. I've got this check accuracy. It just loops through all the test data, runs it through the neural network, and then determines, was that how many correct guesses did it get? And in this case, all of them were correct. So interestingly enough, if I set generate streetlights to a sufficiently large number, like 1,000, it doesn't matter how many iterations I do. I could do like 10 iterations. I might even be able to get away with, I think I have to do 10 iterations because I'm only printing this out every 10 of these. That's when I'm checking the accuracy too. So 10 times 1,000, 10,000. After 10,000 of these, we can, oh, actually, no, in this case, it's 20. In previous runs that I worked on it, it had like gotten to 100 right away. That's those random weights starting with. Sometimes it has a lot longer to go to get it. So it's very fascinating to watch and see how wrong it can start out with, or how right it can start with. Like this one is way off. And that's just the random weights. This one jumps straight to 100 pretty quickly. Anyways, what this taught me was that, yes, this entire plan is going to work. Will the bot be great? Probably not. But will it be good enough to sort of like sort of play the game in my style? I hope. Which means that now, I'll go ahead and save this and close these out. Now I'm switching to making the actual game. So here's my plan. We're going to make the game, and I'm going to set up a mode where it's going to record me playing it, and it's going to record into a JSON object every, I don't know, second or so, the state of the game as I'm playing it. And those will become my inputs and outputs. And that way I can train the neural network to try to play like me. Let's see. What I created here was a very simple Express server, and it's just serving up. And the reason why I'm using Express server is because I am going to be storing the weights probably in like a Mongo database or something, just dumping them in a document store. That way I can keep them in between runs, and I don't have to like retrain after I set all that up. And what I have, I'm using, did I say I was using P5.js? I think I did. Well, if I didn't, it's P5.js. And let's see, how do we do deep learning Pong? We want npx node mon server. By the way, can you hear really faint music? There is music going on downstairs, and it's not too loud for me, but I'm not sure if the microphone is picking it up. All right, so that brings us to you. So this is what I've created so far, deep learning versus Pong. This will be the end result. I'm just gonna have like this be the game field, so I'm not gonna have to like create a border around it or anything. And I'm thinking about leaving, you don't hear it? Awesome, thank you. Also, good morning, Schmerob. I hope I got that pronunciation correct. I have no idea if the size of the, what size of the monitors I'm gonna have. I'm gonna reach out to the event coordinators and let me know like what because usually there's gonna be like a TV that's next to me or a projector, and so if I can get the dimensions of that, I can make this correct, because my training will rely upon that being at least the same ratios. All right, so for right now, if I wanted to put you to the right, yeah, you're too big now. Let's go ahead and change that. So you, close you. I think this, how's this text size for everyone? Because it's a different monitor, it might be changing. Like it looks really big for me, but I don't know what it's looking like for you all. Let's do just pong.js. So here's our canvas. I don't actually know what this size is. 925, so like 920 by, I guess I could do like 600. Works for you on your iPhone? Awesome. If you can read the text on your iPhone, that's really good. Let's see, so let's do 920 by 600. Actually, 700 is fine, I think. Yeah, I see the little white edges at the end. So that is the edge of the game. So this will be sort of perfect for a test. And then when I actually record for the weights, I'm going to have it be set in the proper state for everything. But I'm going to use everything relative anyways, so building it won't matter. All right, so I want to create, last night I created this canvas, I created the ball, and I started creating the paddles. And you can see I have, all right, let paddles, the player and the AI, and then I'm going to have to initialize these. So paddles dot player equals paddle. I'm trying to decide if I want an initializer for it, where then I have to say, okay, now initialize to like the left paddle or the right paddle, or if I just send in, I want this to be the left paddle and then the other one to be the right paddle. Thanks. Switch my drinks around. All right. If I do this, then I could use a lookup table inside of the left paddle, and then its job is sort of like to figure that out. So I think I might do this. Then paddles.ai equals paddle right. And then I want to render both of the paddles. So paddles.player render. Yeah. So I think this is what I want. I'm going to close this and move you over like that so we can just see this constantly. And let's move over to paddle.js. All right, so this is going to take in the paddle side. Viable clan member, good morning. Is TypeScript coming? Probably not today. I didn't want to set up like the TypeScript and doing everything with that. With P5.js, I haven't really found that I need to do that, especially since I'm not planning on using classes, but rather just factory functions and closures and other things like that. And I'm trying to keep this as simple as possible, but we might want to switch over to TypeScript if we feel like it's going to be that important for us. So I'm going to keep the option open. Okay, so I was playing around with different ways to initialize this. I don't think I want to do that. Here's the render that's actually going to render it based upon the location. I have to figure out what this location is. Which means I have to have a lookup table. So let's create that right now. Const side, I guess I'll just use side here, and this will be paddle side. So if we have left, then what does that mean? We can have this, I mean, this can just be an object. Well, actually, you know what? It's going to be this, we need to run create vector. So create vector, and so the X, which is going to be the left side for the location, let's have that just be 0. And then we could start with this with 0, 0 for the left, and then right, it's going to be a create vector. This is going to be width, but we have to subtract the paddle width. So this is not good. This needs to be paddle width. I guess that was another thing with TypeScript. I would have to like create. I wonder if somebody's created all the typings for P5.js. I'm sure that they have. I could probably find it and then pull that in here. So that way it doesn't yell bloody murder at me for every single thing that I do that's actually a P5 thing. Okay, otherwise I'll just use it for the functions. That would be a library I import. Okay, so we have the side, we have this paddle side, create vector this, create vector width, paddle width, and 0. So we're going to start these both at the top like this. All right, so location is going to be a paddle side of side. Let's see if this, well, it's not exactly what I wanted. That's very interesting. I need to give it a width is, oh, right. I set it to like the entire width of everything. The width of this rectangle is actually going to be paddle width, and you need to be paddle height. So here's these paddles right here. Where is width defined? So width is currently a global that P5JS sets for us. So technically it's defined in pong.js when I do this create canvas. And so width is set to 920 and height is set to 700. These paddles look really small. I'm thinking maybe a little bit larger. Width-wise, I think that's fine. Maybe like 200. That's too big. How about 150? $100? I mean, I think this could be good. Let's now get this set into the center. So also I want to move it, well, okay, center first. So in paddle.js, our initial side, so create vector, the left one, X, the Y, so this is actually going to be the height divided by 2. So half of the entire height up here. And then if I do that, it's going to be a little bit offset down. I need to move it up half of this paddle height, which is a subtraction because the y starts up here at 0. So minus paddle height divided by 2. So that puts it right in the center there. So now let's do the same thing over there. All right, and then the other thing is I want this just out a little bit to make it a little bit easier to see. And so that means on the left, we're going to start at maybe like 10 pixels out. Yeah, I think that looks good. And then on the right, it's going to be width minus paddle width minus 10. So there's that there. So I don't currently have like any movement happening. This is just laying out the board. So the next thing to do maybe would be get these paddles moving. So I have to, how do I want to get the paddle moving? When I click a button. So I'm thinking that this is going to be really simple. Just the arrow keys, up arrow and down arrow make the left paddle move up or down. And then that way I can have the neural network, it just chooses, am I pressing the up arrow, am I pressing the down arrow, or am I not pressing any buttons at all? Like those are the 3 outputs it's going to have. Which means I need to go look up P5JS keyboard. I think events. So I'm thinking, let's see, there's key code, key is pressed, key is down. Oh, nice. They have a little ball that follows, that allows me to sort of like play with it with my arrows. All right, so we have draw. So in draw, if key is down, left arrow, and it looks like left arrow here is just a full constant that's set for us by P5. So this, I mean, this works for me. We're just gonna have up arrow and down arrow. So if key is down, up arrow, down arrow. Which means we need a move up and move down. So I'm thinking move up. And we can also have a const move down. Okay, so in move up, what's happening is we're just telling the location to, we're just updating the location. So if we do the same thing that they do here, that's going to be a paddle side. Well, actually, we can set our speed and then update that by subtracting two vectors together, or I can manually just update the location y. I don't know which way it would be better for me. I could do, unfortunately, move up speed, move down speed is going to be a vector with x and y. Y is negative, positive. Oh, okay. Maybe I can do this. Const speed equals, so if I say something like 5, move down or move up is a negative vector and move down is a positive vector. But other than that, they're going to be exactly the same. So I wonder if I can just say this. Speed is going to be a, okay, if I say 5, that's a scalar that I'm going to multiply in order to scale up. I don't want to like have to create the vector every single time. I'm thinking that if I just like const movement it's like this is like normalized movement. So create vector, we want not to move an x value, but we want to move in y, and I'll set this to 1. And now I can multiply this by 5 to scale it up to like the right speed. And then I can multiply it by a negative speed if I want to go up. So this is going to be location dot, I think it's dot mult, and where it's going to be the normalized movement. So if I do this, when I hit the up arrow, it should just move up very slowly, which itself would be multiplied by 5. This feels like I'm making it more complicated than it needs to be. What if I just set this to 5? And then I can multiply this by -1. And I don't think this is going to be mult anymore. I think this is now going to be add. I think that's what I'm going to go for. I need to test this to make sure that's working, which means key is down. So in draw, if key is down, up arrow, then paddles dot player move up. Didn't I put that in here? Oh, I need to actually export this. Huh. I don't know why I didn't see that. Not a semicolon there. All right, let's see if this works or if I've got it horribly wrong. Hey, look at that. So it kind of moves and then it resets itself back to 0. So I've clearly got a problem going on there. I mean, it's trying to. So like on 1 or 2 frames, and then it's resetting back. So where am I resetting the location? Because this shouldn't be being called more than once. Render's not resetting location. Now I'm doing location.add, normalized movement, mult, -1. Oh, is this not a permanent? I need to look at their math. So to create vector, where's the vector math? P5 vector. Okay, so I used create vector to create the vector. I then do location vector. And I add this vector. Oh, just these scalars to it. And then updates to be this. But it could also use the static method off of p5.vector, which will return a new vector. So I could also do that. All right, so let's figure out what we're doing here. Why is this refusing to go up more than like one line at a time when I'm holding the up button? We're setting location to move up. Actually, let's just console log location out here. I'm betting that it's resetting back to not great. Yeah, so see how, I don't know if you can see that. The Y is changing to 295 and then it's immediately changing back to 300. So that's my problem, is that it is resetting. So it is adding, it is changing it, which means the next time it comes through the render, the location gets updated. In Pong, am I doing anything? So ball.render, paddles render, and that's it. Function setup shouldn't be run more than once. So render fills with the color, set the location. All right, what happens if I just change it? What if I say location.y equals location.y minus 5? Oh, okay. So you're fine forever now. So my my math was not working on it properly. Oh, I think no, the add, I would think that the add should be able to do that. I could create an entire velocity vector, and have that added to the location vector, and then constantly set that each time. Because I could set that right here where I can say, okay. I mean, also this is just fine. I don't know if I really care. It seems smooth enough. I don't know if I really care to be super proper about it and not update the vectors on their own, but rather update them through just vector math. Because if I do this opposite way, I would say location.x equals location.x plus 5. And in reality, our speed would be 5. And that's what this is going to be. And then in Pong, no. Oh, yeah. That's fun. You're right. Location at Y. However, that would be an interesting game. Your paddles can come out to meet each other. Move down. You're right. Location dot Y. All right, so now we can move up and down with our arrows. It's not the smoothest movement that I've ever made before, but we would need to like have an entire velocity and acceleration and do a little bit of gravity tweaking to sort of like make super smooth movement. And I'm okay with just having it be like this. We might even want to play with the speed being like 15. I feel like this is going to get really hard for me to play, and it would be a lot easier for like a bot who would potentially every frame be getting a chance to decide what is it going to do. All right, so what do we want to do here? Let's stop it from going up off the top. So we should probably have a function. Const, new game entirely. That's like essentially tennis pong, because then you can have like the net at the middle and you can't move past that. Maybe two players, one can stay in the back, one moves forward. Make it a little bit interesting. Stop paddles at edge of screen. Stop at edge. So we're just going to run this function. All it's going to do is it's going to determine, are we at the top? So if the location dot y, so this is going to be the top of, I was going to point at that, top of the paddle is above 0. So if that's less than 0, what do we want to do? We want to set the paddle back to 0. So location dot y, set this equal to 0. And that's pretty much it. I don't have to like reset any movement because it's just whenever you're holding the button down. And we want to do this at the same time. So else if location dot y plus, so I can do this on this side or on the other side. So I'm going to say plus paddle height. If that is greater than the height, then we want to set location.y equal to height minus paddle height. Oh wait, I need to call the functions if I want to actually run it. Stop at edge, and let's head over to Pong, and maybe down at the bottom here we'll then say paddles dot player stop might as well do the AI too. All right, so now it can't go up or down past the edge of the screen. So perfect. The next thing would be to try to make it so that the ball can bounce off of the top and the bottom. And then the bouncing off the paddles is the hardest math for this game. And that's mainly because we have to like make sure the ball is like beginning to clip into the paddle itself, which it's not too terribly hard, but I usually screw it up once every time that I start doing it. So let's go up first. Having the ball be a circle actually makes it easier. So let's open up ball. And kind of want to change this. Const render equals, there. Everything's an arrow function inside of the factory function. So this is going to be bounce on walls. And all we're checking to see are we clipping into the top or the bottom? And if we are, reverse the directions. So if location, so this is going to be .y, and I'll do half of it right now. So if location.y is less than 0, so that means the location is going to be the center of the ball. So if the center is right there, and I kind of want it to be here. So if location.y plus, and it's going to be the size divided by 2. Unless, of course, the size is radius, then it's just size. So we'll have to, if we like bounce here, then I'm gonna have to use just size. Okay, location plus y plus size divided by 2. If that's less than 0, first thing we want to do, reset the ball to that position. So location.y equals just the size divided by 2. Okay. And then also, if it's coming like this direction, the x stays the same. We're still moving to the left, but the y has to reverse. So that's actually going to be, here, I'll just do location dot y equals location dot y times -1. So that should handle the up. And the down this is going to be the exact opposite. So we're going to subtract the size divided by 2. So if that's greater than height, and we're going to be height subtracted from size divided by 2. And then also we're going to reverse. So location.y times -1. So ball dot bounce on balls. Of course, the ball's not moving, so we can't test that. So we also need to have a movement. So we need a speed. I have no idea what speed we want, so I'm just going to arbitrarily choose 10. And a direction. So our direction, what do we want to do? So that's going to be our velocity. And that's going to be a vector of like a point somewhere around where it's going. And what we can do is a little bit of trickery here. So velocity is going to be a create vector. Let's say we want this to be just negative like 5. So that's this direction. And -5. So that's up in this direction. But because I want the speed to be the same no matter what, and if I use like, 15 and 15 to go down in this direction, that would be completely different speeds. I'm going to have to normalize this vector. and then multiply it by speed. So velocity dot, I think it's normalize. Oh, it's just norm. Because that makes it 1 over that side. Okay, so norm. And I think norm is mutating. Where's the normalization? Or here, description. Oh, okay. That's not what I wanted. I want the normalize on the actual vector. Oh, it was normalized. Okay. V dot normalize, V's components. Okay, so I was correct. So we're going to normalize velocity to be between, so both the x and y are going to be between 0 and 1. And now we can velocity dot mult with the speed. And then we can have like a move. And we're going to add, so location dot add velocity. So velocity is gonna, we're gonna have to, this bounce on walls is gonna have to change. It's gonna have to be the velocity now. So the velocity is being added to the location, which is causing it to change. And of course, like always, I need to add move here. Ball.move. And so the ball moves, and of course failed to bounce on a wall. So that's great. However, it's always going in the same direction, which is fine for our test right now, and it's always going the same speed, which is also fine. So let's actually make that work. So we have this bounce on walls here. I want to make sure that that was the same. Okay, so if the location of y so the location of y plus the size half, we do need to set this back to location, so like just place it there, but now we want to reverse the velocity. Else if location.y minus size height location equals this, and velocity gets reversed. It doesn't look like that was part of, oh no, that was the problem. Okay. I want to set this speed down to like 1 so I can really see that contact. Is it going in? So it went fully past the, it was the bottom of the ball. So where are we going to do that? So, okay, the top. If the location at y plus the size divided in half. So this is completely wrong. Is less than 0. Oh, because I moved it down and then it went up. I need to do minus the size. And it sounds like I just need to do the size. Let's try this again. This, by the way, easiest game of Pong ever if I kept this speed. That's lovely. So it got stuck on the top there. That can happen sometimes. I think I should set this to like 1 or 2 pixels more. So we're going to set the location.y to, oh, just the size. That's what we need. Surfy, hello, good morning. I mean, that's interesting because it stops too close. So I think maybe it does need to be divided by half. Yeah, it bounces right here. So let's try divided by 2. Things are going well. We're getting the deep learning working. There we go. That looks right. And now we're making the game. Okay, so let's now do the bottom. So let's make sure that we got this right. So location.y, this needs to be a plus size divided by half is greater than height. Location.y equals height. Let's see, I think plus size divided by half, and then we reverse the velocity. So let's set this to 5, 5. And now we'll go down and to the right, which I realize is behind me. So let's actually do negative 5, 5. Oh, I guess like my camera is not like completely blocking it. All right, well, it just disappeared off it like died. It didn't even like just slowly go off. It just disappeared, which not exactly what we were going for. Did we get an error message? Is that why? No error message. Also, we still have this console log somewhere. So is it really just disappearing at the edge, or is it going off? Yeah, it's just poof, gone. All right, so location dot y, which means it probably like jumped and teleported down off the edge. Okay, so location, so if the location dot y plus size, I'm guessing that this is working because it's like hitting this and then it's doing the thing that we don't want it to do. So location.y is set to the height. That's down, that's right here. And then we do want to minus the size to bring it back a little bit. Let's try that. And of course, once it gets down there, it gets stuck. It won't ever be able to escape because it's now in this like flip. There we go. So now we've got that working. We can set the size back to 15. And more importantly, we can start doing some interesting things with this. So because we're normalizing our vector, we can say, okay, I want to go a random between -1 and 1. And random between -1 and 1. So it's always starting at the same speed. It's now starting in a random direction, which I think is fine. It's probably a little bit off. Also, the like the dots sort of multiplying themselves. That's just, it's moving fast enough, and the refresh rate is not high enough that we can actually see that. I could fix that by doing some fun things with acceleration, but this doesn't need to be like a super playable game. I think I can maybe start this at 10, maybe even slower, like 7. And I have a thought. What if we increase the difficulty level by making the speed go up every time it hits a paddle? Maybe every n times it hits the paddle, we increase the speed by 1. I think I might want to try that like later at a later time, just to see whether or not the AI would be able to handle that. For right now, probably just something like a speed 10. And then just play straight from there. And that'll be the first iteration through, is can we make the bot actually work with that way? All right, so with that, let's now make the, because we can move the paddle up and down, let's make the ball be able to hit the paddle, because right now it just goes through it. Which means we need, do I want to hand the paddle the ball or the ball the paddle? I'm thinking ball the paddle. So const collide with paddle. And we're going to take in a paddle. Okay, so we need to determine, first of all, are we on the sort of like the same level as the paddle? So the Y. There is this is like I think it's like a bounding box collision pattern. I forget the exact full technical term for it, but it's basically, okay, is any of us overlapping? So like our bounding box overlapping with this bounding box. So we need to determine, are we between, like below this and above this line? So if, so location.y, so that's the center of the ball, if that is greater than, so if that is greater than the paddle.location.y, and because we know the paddle location is actually this corner, this top left corner right here, that's all we really care about, is this line. So if we're greater than that, and location dot, and it's actually location. So if our location, oh no, you're right, location of y is greater than paddle location of y, and location dot y is less than paddle dot location dot y plus paddle dot paddle height. Okay, so are we greater than this and are we less than this? Then we're right in this zone. What we can do is we can actually change the color just to show are we in that zone. So we'll do a color equals, how about like 100? So we'll dim it down significantly, and then we can have an else. So reset it back to 255 if we're not in there. It's maybe moving too fast. Let's go back down to like speed 5. Oh, that's too hard to tell. Oh wait, you know what? We need to run this function. Collide with paddle. That would be nice. All right, so we're gonna ball dot collide with paddle, and we're first going to hand it the AI paddle. So that would be paddles dot AI. And then paddles dot player. Oh, look at that. It just doesn't move anymore. What are we doing with this? It must be crashed. Cannot read property y of undefined. All right, so we can actually take a look at this. It is location.y. So I don't know exactly which one it is, but I could put a breakpoint on this, hit refresh. So paddle has no location, no public location to it. So that's the problem. So paddle needs its location made public. So now there is a location and we can work with that. So if I take you off, oh, I still have a problem. Assignment to constant variable. Okay, ball 34, line 34. Color equals. You're a let now. Okay, now what? Assignment to constant variable. Another one. Wait, I thought I saved that. So, oh wait, that's paddle. Ball. Yeah, if I had looked at the right file, I would have seen the line number would have been correct. There we go. I should probably like, that's too impossible to see. Like, oh look, we can actually see that it's in between there. Let's make this like color equals like 10. That still doesn't feel like it's hitting in that. I am filling with the color. Now, to be absolute sure, I can make color a object with red, because I think it's RGB. So red would normally be, we want white, so 255, blue are RGB. So we can do green. 255, blue, 255 to make this white, and then I want you to be color. Essentially, this is now going to say color dot red equals 255, color dot green equals 0, color dot blue equals 0. Now this can be a const again. And this gets reset. So object argument is not a valid color representation. Okay, so apparently that's not how I do colors in P5. Oh, do I have to just spread it out? Well, apparently I can just do a named fill. I mean, that's easy. Let color equals white. Color equals red. Set color back to white. Yeah, it's not setting to white, so this is not working the way I want it to. We could also console log to see if it's being caught in here. So in between petals. And not being caught. So collide with paddle is available down there. Collide with paddle is named correctly. We're passing it the AI paddle and the player paddle. If I don't worry about the AI paddle right now, if I just worry about the player paddle, that's not working either. So let's think about this. We have our location.y, and we're greater than a paddle's location.y. So let's just start with this. If we're below the paddle, can we make it turn red? Yes, okay. And it turns white as soon as it goes above the paddle, so perfect. We also need to turn white back again when we're below this. So we need to be below the paddle and above the paddle. So location.y is less than paddle.location.y plus paddle height. Is paddle height actually... No. Am I getting like not a number and that's the problem? Okay, I need you. There we go. There, okay, so it's in between paddles. So it turns red when it's in that horizontal line. Now we need to set it so that way if it's also in the X. So if it's overlapping in here. So I'm just going to make this a separate if in here so it's not like this gigantic massive if statement. So if location.x, so the left right of the ball has to be to the left of this line right here. And it's really the left edge of the ball. So it's the ball minus the amount. So it's location.x minus size divided by 2. So that's the left edge of the ball. If that is less than right here, this edge. So if that is less than paddle.location.x plus, so that's right here, and I have to add the paddle height, the paddle width. Do we have paddle width? No. Okay, so that's telling us if we're right hitting here, rather if we're left of this, then in that case we want to, okay, so if location.x is less size, that's the left side, if that's less than this edge right here, we're clipping with it. We have to also make sure we're not like just behind, because I can see the ball's coming down like this, we miss it but move in front of it, and it might then say, hey, we're now like to the left of this and within the band, you're hitting it, right? It's like, no, we need to make sure we're actually inside of this box. So we also have to be to the right of this far edge. So, and location.x I don't know if I want to do the right-hand side of the ball. Because even if I'm coming down here, at most, the center of the ball can hit. Because if I want to hit here, I don't know if I want... I think I might want to say, like, if the right edge of the ball is also hitting this. So... size divided by 2. So if that is, that has to be to the right of here. You're right, that is paddle width, paddle dot. Thank you for that. Also, I'm going to turn this on. It's a little bit late, I know, but it doesn't turn on automatically, so you can let me know when I make horrible mistakes like that again. It's not really a horrible mistake. We would have found it out pretty quickly when it yells at us about paddle not being defined. Okay, so the location plus the side, so that's the right side of the ball. If that needs to be, that actually needs to be to the right of this line, doesn't it? So is greater than paddle dot location dot x. We'll just make it to the greater than the left side, and we'll try this. Okay, so if both of these are true, we're colliding with the paddle, which means that we're going to do the exact same thing that we did here. We're going to say location dot. We need to take the x and move it to the appropriate sides. This is the only interesting thing here, is that we need to know whether or not we're the left paddle or the right paddle in order to like move it to the appropriate spot. So we're going to handle the left paddle first. So location dot x. We have to now set this. We have to shift it to the right, so it's going to start here. So paddle dot location to the x plus paddle dot paddle width plus the size divided by half. So this unfortunately will like teleport. If it hits this paddle, it's going to teleport it to this side, which is less than optimal. But we can figure that out in a bit. We're working on this one first. So let's see if we've got that working. You head towards me, please. There we go. I mean, that was really interesting. We it hit it and then sort of rolled along the side, and then it just sort of continued going. So the velocity actually needs to be reset too, which I forgot to do. So we set the location. We also need to set the velocity dot x equals velocity dot x times -1. Left, please. There we go. Yeah, now we can bounce the ball. I'm not thinking. I mean, I could add in. Do we want to add in where if you hit it on the edge, it sends the ball off at different angles? I'm not sure. We definitely could do that. Calculate how far off the center of the paddle we are, and then the ball goes to an angle depending upon that. That will add in a little bit of. I'm thinking that we'll start with this simple version. We'll get this Pong going, and then we'll check to see, okay, can our deep learning algorithm handle this? If it can, then that's like one checkpoint, and we at least have something cool to do. If it can handle that, then we could try adding in a different, increasing the speed or adding like a complexity to the paddle, and then seeing, okay, can the network learn this too? And if that answer is yes, then we can keep on adding complexities until our super simple network can't handle it anymore, or we run out of time and we have to present. But I'm thinking this is an excellent stopping point. We've got the left paddle working. I am going to create, do I have a README? I do. So next step, this is going to be, we have to make the ball, so like have ball hit properly off the right paddle. Right now, it's going to hit the right paddle and teleport to the right side and try to reverse, and then weird things are going to happen. So I really need to determine if I'm on the left paddle or the right paddle. So there might be a little bit of refactoring in order to get to that step. But I'm going to close you, add you all. Yeah, increasing complexity sounds good. Yeah, I feel that if I get the network running with the basic one, then I don't have to like rewrite the network part again. I just like change the inputs and the outputs and try again, like rebuild it. And understand why the network. Well, we'll see about that. I don't know if my understanding of it is quite that good yet. But maybe by doing this, I'll get a better understanding of the limitations of this type of a network. So we created basic game, ball is moving, and hitting left paddle. And so that's being sent up. Actually have a new Git repo for this. I don't think no, it's not showing up here. I'm calling this deep learning versus Pong. And I'm going to share that out with all of you. So feel free to take a look at the code here, fork it, download it, add issues if there's clearly things that I'm doing wrong. Douglas Correa, good morning. What happened with my Rust streams? Did I stop it? Temporarily. I'm actually planning on going back into Rust shortly. So in maybe a few weeks after this conference talk. But yeah, so the Rust streams ended up stopping due to a series of unfortunate events. I got a concussion. I had to take a break from streaming. During that time, I lost my job and I had to get a new job. New job was in a stack I've never developed in. So then I spent most of my programming time learning the new stack. So now I feel I'm ready to go back into Rust for the fun times. So I'm almost thinking that we're going to redo deep learning versus Pong in Rust after the conference talk, because that would be a lot of fun, and reintroduce myself to that. Either that or go through nature of code in Rust, because that would be great too. Either way, that's the plan. The conference is next week, Thursday and Friday, and my talk actually is on a schedule now. So we can go to develop Denver. If we go to events, you can download the full schedule. And this is the first day. I am on day 2. And you can see here, live stream with me. That's going to be at 10 a.m. Mountain Time. Obviously, if you're here in Denver, you can come, and I'm in Big Trouble, whatever that means, like wherever that really is. I think it's the name of the room, or I don't think there's a company named Big Trouble. That would seem weird. Just sort of like to right afterwards, Coding Garden would be on with CJ. So that will be really awesome. I'll be able to just sort of finish my stream, pack up, and then watch his stream right there in the audience. We're hoping that the internet is going to be good enough that we actually get a live stream. At the very least, I'm going to record it and have a YouTube video, and I can also put that up on Twitch. We can do I don't know, I'll just stream and then play off that video in case it doesn't work. I don't know. I don't think that the conference in general is going to be streamed. In the past, they've just done recording, and then half a year later they get the videos up on YouTube. And I could show you that if we go to youtube.com. So this is the Develop Denver YouTube channel. It has all the videos from the previous talks. Actually, you can see I did one last year, getting things done for software developers. So that was my talk last year. And it's usually really awesome content. I'm still sort of like going through some of the ones that I wasn't able to watch. But yeah, that's the plan. You're in Brazil right now. You'll be in St. Louis at that date. Either way, too far. Yeah, I can definitely see that. But maybe one of these days we'll I'll meet at a conference or something, and that'll be a lot of fun. All right. Well, regardless, it is time for me to get ready and head off to work and do all that stuff. So I'm going to shut the stream down. But thank you everybody for stopping by. I'm looking forward to completing this game, getting the deep learning network working on actually something we can see it working on, and then sort of moving forward to whatever new things we can do. So with that, I hope that you all have a great rest of your day, or night, depending on where you are. And I'll see you next time, which the plan is Friday at 6:45 a.m. Mountain Time. See ya!